We have looked at a test where we were not able to assume equality of variances and we didn't know the theoretical variances. Now in this case, we look at the test where the theoretical variances are still considered to be unknown, but we are allowed to assume their equality. So since the variances are unknown, we still have t procedure, but the form of the standard error changes a little bit. So now, in our standard error, we have so-called pooled variance, denoted as SP square, and it's given by this formula. So again, the formula is straightforward because we only have sample variances and sample sizes in here, and then that pooled standard deviation in here is multiplied with the square root of inverse sample sizes. Then the t-statistic by the general formula is the same as in the previous case. So we are just dividing the difference between the sample means with the theoretical delta. We divide that by the standard error. It's just that the formula for standard error now is different, so the final formula looks a little bit different than in the previous case. Also, the number of degrees of freedom here is much more straightforward. It's just the sum of the sample sizes minus the number of the samples, which is 2. And the decision in this case is done the same way as in the previous case. So again, since it's a symmetric test, two-sided test, so we accept null or we fail to reject null if our t-statistic is statistically close to 0, meaning that it's within plus minus critical value, and we will reject null hypothesis if it happens that our t-statistic is significantly far from 0, so that it exceeds critical values.